We want to add x over x plus 3 to x plus 5 over x minus 4. In order to add these, we have to find a common denominator. The common denominator is x plus 3 times x minus 4. So now we want to write x over x plus 3 with a denominator x plus 3 times x minus 4. In order to do that, we're going to have to multiply x plus 3 by x minus 4. That'll give us the denominator that we want. But we also then have to multiply the numerator by x minus 4, because otherwise we would be multiplying by something besides 1. X minus 4 over x plus 4 is 1. Multiplying by 1 doesn't change the value of what we've got. So by doing this, we haven't changed the value of x over x plus 3. X plus 5 over x minus 4, we're going to have to multiply the denominator by x plus 3 in order to get our common denominator. And then, of course, we have to multiply the numerator by the same thing, with the result that we've multiplied the whole fraction by 1 once more, not changing its value, just changing the way it looks. Okay, well, then we get x times x minus 4 here, x plus 5 times x plus 3 here, and by now we know that we're going to get the same denominator. I'm kind of skipping a step where I could have written all this out with this fraction with this denominator and this fraction with this denominator, but I took the liberty of skipping a step here. So we now have this, and then we just expand and simplify the numerator. X times x minus 4 gives us x squared minus 4x. X plus 5 times x plus 3 gives us x squared plus 8x plus 15. And adding that, we get x squared and x squared, 2x squared, negative 4x and 8x gives us 4x, and we have our 15. And there we have it. Now, we do want to try to factor this, but the 15 is way too big. There's no way we're going to get a number as small as 4 here. And we can verify that by checking the discriminant with the quadratic formula. It would be the square root of 4 squared, which is 16, minus 4ac, which would be 4 times 15. 16 minus 60 is going to clearly be negative, and there's just no real factors, or there are no binomial factors of this expression that have real coefficients. You could get complex coefficients, but not real ones. Okay, so that's pretty straightforward. I went through the whole class without a plus sign there, didn't I? Didn't need to make it in yellow, but we'll just leave it. Okay. So 1 over x squared plus 5x plus 6, and I know what it was. I didn't go through the whole class that way. These were supposed to be minus. I'd originally written them plus, so I cleared them out, but then I forgot to correct them. And I've apparently done the same thing here, so let me just put those in. And we're going to have minuses here and here as well. Okay, now the people in class knew what was going on, so that really wasn't a problem, I don't think. Hope not. Okay, so I factor this and I factor this. So I get 1 over x minus 3 times x minus 2 and x over x minus 3 times x minus 1. What's the common denominator? Well, we could just multiply this denominator by this denominator. It would be a common denominator, but we're better off using the least common denominator. So maybe I ought to put an L in front of that, least common denominator. Doesn't look like a very good L, does it? Okay, so we're going to have x minus 3 and x minus 2 as factors, and we're going to have x minus 3 and x minus 1 as factors. Well, we've got x minus 3 here. If we just add x minus 1 to the x minus 3, x minus 2 we get here, we've got every factor of every denominator collected into this denominator. Then we proceed as usual. To get our common denominator, we have to multiply this first term by, well, denominator has to have an x minus 1 in it, so we're going to multiply by x minus 1 over x minus 1. Here, the x minus 2 is missing, so we're going to multiply by x minus 2 over x minus 2. And then we have 1 times x minus 1 and x times x minus 2 over the common denominator. And we expand. We get x minus 1, and here we get x squared minus 2x. Collecting terms, we get x squared minus x minus 1. Worth trying to factor that, but it doesn't work. You don't get any common factors. There's no big advantage. And you can also, well, your discriminant is not negative. It's going to be square root of 5. So you will have real zeros of this, but you're not going to have any integer or even rational factors. So we leave that one unfactored. Okay. Factoring question coming up next. We'll do that in a separate video.